Hi, my name is Scott from the Economics Tutoring Center at ASU. Today I'm going to be doing an example problem from the Poisson distribution, and I'm going to use a little bit of Excel. If you need a recap on anything about the Poisson distribution, we have another video on this playlist, so you can check that out. But first of all, we have a random variable x, and I'm going to say it's a Poisson distributed with mean 5. So, quick recap, the probability density function of the Poisson distribution is this one here. So lambda is the mean, and e is just the constant e from the exponential function. So this is how you get the probability that this random variable takes on exactly this value, little x. And so we can ask a question like this. So let's say x represents the number of calls that a call center receives within the next hour. So it's a random variable. Let's say we want to know the probability of getting exactly 4 calls. So when we have exactly 4 calls, we can apply this PDF formula. So for example, that would be the probability that x equals 4. We'd get, so lambda, which is 5, it's the mean 5, to the power of 4. E to the power of negative 5, and 4 factorial. So that's just plugging in 4 for x, 5 for lambda. And if you calculate that, you'll get about 0.175. And so that works fine. Now let's say we want to ask this other very natural question to ask. What's the probability of getting 4 or fewer calls? And if we write that in probability notation, that's the probability that x is less than or equal to 4. And you'll see in the other video that I mentioned, we don't have a good formula for the cumulative distribution function of the Poisson distribution. So we can't easily answer a question like that. Now we could say, well, this equals the probability that x equals 0 plus the probability that x equals 1, all the way to the probability that x equals 4. And that would involve 5 calculations, which isn't too bad. We could certainly do that. But let's say this is 20. Then you're not going to want to use this formula 20 times to get this answer. So I will show you how we can do this or this in Excel. And that's what we're going to do next. So now we're going to look at how to do these questions in Excel. So again, we have that x is a Poisson random variable with mean 5. And then our first question we want to ask is, what's the probability of getting exactly 4 calls in the next hour? And so I showed you how to do that by hand. We can do it in Excel. So just go into a blank cell, let's say here, equals Poisson, and you can see it comes up, .dist, and then if you click on that, it opens it up. So you can see here it has 3 different arguments that you need, or inputs you need to type in. So first of all, it wants x, and by that it means what is the number you're interested in. So if you remember my notation before, it was what's the probability that big X equals little x. So we want the probability of 4 calls. The next thing we have to input is the mean, which we're given is 5. And then it asks, do we want a cumulative probability or not? And here we want the probability of exactly 4 calls. By nature, that's not cumulative, so we type in false. Oops. And then, oh, there we go. Hit enter, and we get the same answer, 0.175. And so, again, here's the formula really quick if you want to jot that down or type it in yourself. Then our next question, which we couldn't very easily do by hand, is what's the probability of getting 4 calls or fewer? So if you remember, one option was to find the probability of getting 0 calls, 1 call, 2 calls, all the way up to 4 calls, and adding those together. And we could do that by doing exactly what we just did. So Poisson.dist, whoops, open the parentheses. So instead of typing in 0 for the x, I'm going to reference that cell, and then the mean was still 5, and we want the probability of exactly 0, so we do false. Type that in. So here that is again. So that's the probability of 0. Now if we drag this down the rest of the column, you can see that the cell reference changes. It goes down with the formula. So now we have the probabilities of 0 through 4, and you can use the sum formula to add those all together. And this is one way to find the probability of getting 4 or fewer calls. Now again, that may not be the most efficient way, so the other way is to use the same formula. So we can just click it once it comes up. If we want 4 or fewer calls, we use 4 as our x value. Our mean is still 5. And now we want a cumulative probability. And so instead of false, we put true. And there we go. We get the same answer here. So there it is, as we get by summing up these individual probabilities. And note that this works because the Poisson distribution can only take on non-negative integer values. So these values are all of the possible values that are 4 or less. And maybe really quick, just to verify one other question, we could ask, let's say, what's the probability of getting more than 6 calls? And so that is the probability that x is greater than 6, and that is actually equal to the 1 minus the probability that x is less than or equal to 6. We know that the probability that x is less than or equal to 6 we can do with the Poisson distribution function. So now we use 6 as our x value. The mean is still 5, and we want a cumulative probability. So this is the probability that x is less than or equal to 6. And then we can just here insert 1 minus that. And that's the probability that x is greater than 6. So you can see in Excel, it's a lot faster to use the CDF to find these cumulative probabilities. So that's all we have for today on the Poisson distribution examples. I hope it helped. If you have any other questions, just ask your instructor or come into the tutoring center.